Welcome back to another video. So this is a case study. As you can see, I'm within Blender. If I will enable the viewport shading, we're gonna see the model output from Tripo. This in the middle will be from CSM, and the ones over here from Vizcom. So before I'm gonna get started, I'm really impressed by the fact that the model from Tripo and the one from CSM are so close in regarding the size. These are the models from Vizcom, and as we can see, these will be a lot larger. Now, let's start with Tripo. This is the mesh, and I use this as an image reference within all three tools. So the file format in this case was GLB. If I'm going to save this as a USD, we're going to see that I will need additional 5 credits. And we're going to have that downloaded. So the download has started. I have mostly chosen the GLB file, but for CSM, I had to use a different file format. Because when I wanted to decimate, the model didn't act that good. So I downloaded this now. Let's see the file format within the desktop. So this should be within downloads, but let me just check. Okay, so the file model was USD, not FBX, and this is okay. So today, this is the file. We're gonna see this will be 20 megabytes, so a lot larger than the GLB file. If I will import the model, we're gonna have it over here, and I also rotate it 90 degrees, but onto the other direction. So minus 180, and this will be the mesh. So we see the edge count over here. This will be the GLB, a little bit heavier than the one over here, which will be the USD file format. And over here in the middle, I added the decimated model. So in this case, we see I decimated this to 0.1. I will also decimate this to 0.1 without keeping the original one, because I want to compare the overall topology over here. So we see this one with 0.1 will have 50k faces, this one as well. So if I'm gonna go lower, so 0.05 over here as well, you're gonna see the following topology over here. So we see it over here on the GLB that we have a middle seam. If I will shade this, automatic smooth, let's see if those will still remain. So it will look like that with that, but over here we're gonna see that the geometry will be a little bit better. So keep that in mind, that the topology on the USD file will be a lot better than the GLB file, as we have over here a middle seam added. Within the original mesh, it was not that visible, as you can see it over here, but we can clearly see that within the one decimated. Now, for CSM, we have the following model over here. This is the original one. Okay, sorry, no, this is also decimated. So this is the original one, and this is the model. I exported this as a GLB file, and afterwards as a USDZ. I decided to use the USDZ file format in this case because this is the one, so this is a copy, and if I will decimate this with a ratio of 0.1, you're going to see that the mesh decimation will look like this within Blender. So the faces are not being stitched together, but over here with the USD file, this will work fine. And we're going to see that model decimated. If I will go with a ratio of 0.05, this will be the output model. So in this case, 7.6k faces. If I'm going to compare this with Tripo, which will be this one, we're going to see that with 0.5, it will have 24 1000 faces. So let me just bring in the one decimated from Tripo, the one from CSM over here, close to each other, because I want to analyze the topology over here. If I will further decimate this to match over here the, let's say, the total face count, let's say that I will go with 0.03 in this case, this will take me to 14k, so this is still twice the poly count for this model. So if I'm gonna go with 0.015, this will have a similar face count. But we see overall that the model from CSM has a lot more detail embedded within the topology. We see it over here on the arm, this is much cleaner, and this is why I consider CSM to be a good solution, mostly because of this topology. We see how well is that defined. Now let's take a look at the model from Vizcom, which will be this one. And this will be the original one, and this is the decimated. We see the original 100k faces, and this will be the one decimated. As you can see over here within the GLB file, we're going to have various meshes like that. So I will just jump over here and I will export the USDZ file. So we see that being prepared for export. We have it ready. Let's go within Blender, File, Import. And we're going to have the USDZ. This will be the model. It will load over here. And I'm going to add it over here. Now, if I will select it and decimate it, let's go with a ratio of 0.1 in this case. This will take it to 10k faces. And we're going to see that, that geometry. So if I will go with something lower, let's say 0.08, maybe even 75, to match the face count from CSM, this should be that amount. So let me just grab all of those, add this as well to the line over here, make it a little bit smaller. And these are the outputs at around 7k. And if I will enable the wireframe, we're going to see that the wireframe will look like this. So I'm really curious what's your opinion regarding this, because I consider that CSM does the cleanest topology over here, and that is clearly visible when we're gonna go and have this decimated. So around the same face count, it will be like this. Keep in mind that over here we also have this remote that also eats a lot of geometry for those two models, and over here for Vizcom is just for the dog shape. If I will separate this by loose parts, we're going to see that 600 faces will be within this remote for the CSM model. And if I will do the same over here, so not by selection, by loose parts, let me just select that again. So this is the model P, loose parts. Press tab to leave that, and the remote again around 600. Now we see that overall I think that the model from CSM did the best job over here. If you're going to take a look over here at the nose, the topology of the decimated model will look like this compared to the other. Okay, so I'm really curious, what is your opinion regarding this? What is your favorite generative AI tool? For me, I still like all of these three solutions. So Vizcom is amazing for industrial design application. CSM has a good topology, but Tripo has some really good animations and also textures. So let me know in the comment section what is your preferred generative AI tool.